Hi guys, this is Oliver from Jarangan, Thailand. Today we will have a look at our CNC station tutorial. In the first part of the video we will look at the programming situation. So we have the program ready and we will explain you in detail what we have done. And in the second part we will see the application running. So we have a workpiece holder with two workpieces here. We have the gripper. Inside the CNC station, we have a simulated chuck. So it's a 3-jaw chuck here, pneumatically actuated. You can see here in the control box, which is open on top, we have here the digital outputs set. So we don't get a signal back if, for example, the gripper is closed or open. This is a very easy setup for educational purposes only, right? Okay, here's an overview of what we will do in the first part of the video. First, we will set up the tool center of gravity so the robot is able to balance the additional weight of the tool that it is added. Second, we will go into the programming. I show you what variables we have set up, how you set up the variables, the initialization part of the program. Then we will have a case evaluation, and then we will program the cases in detail. And last but not least, we will have a thread that will simulate machine feedback. Okay, the communication in this for this tutorial is done by digital IOs only. So this time no Modbus. If you would like to see how to set up Modbus with AUBO, you just go to the PCB station tutorial, or you can go to the VG10 setup that my colleague Enrico set up. All right, let's go into the programming. First of all, we go to Settings, Robot, Tool Cal, and here we see we have a Zimmer Swivel tool set up. So what we need to do is go to the Dynamics Cal, and here you see we have added the Zimmer Swivel. You just give your Dynamics a new name, put in the payload, and then measure at the tool, if you don't have it in the documentation somewhere, where is the center of gravity. Please keep in mind you need to add it here in meters, not in millimeters or centimeters, in meters. Make sure, but the program is already limited from minus 0.5 to plus 0.5 meters, so you cannot make a big mistake here. So in my case, is 650 millimeters, right? 65 millimeters. This would not be able to add here in millimeters. So after you click on add, you will have this in here. We ignore the kinematics calculation, go directly to Tool Cal. Here also we add a new tool name. Choose the correct dynamics here, the Zimmer Swivel, we just edit and add this here too. So the next step would be you need to log out with this symbol over here and choose the right tool that you have set up with the robot and start the AUBO PE, the software again. Okay, we go on to the programming section. Maybe first we can go into the IO states here, the user IOs. You see the overview of all your inputs and outputs and the states here. The outputs you can change here manually. Just click on the one you need, and then you can control the output down here. You can set it, it's too low, set to low right now. You can set it to high and send. It would activate that output. So output 2 is the swivel unit of the gripper. Output 3 is the gripper itself to open and close the gripper. And output 4 is the chuck to open and close the chuck. So here we have a normally closed setup. That means when the outputs are low, as they are right now, the gripper and the chuck, they will be closed. That's important to know for the programming later on. So here you can see our program that we have written for this. We have the initialization, we have a main loop, and we have the thread in the end. But first of all, let's go to config, variables config. So as you'll see, we have two workpiece holders. So I called them here variable workpiece slot 1 and 2. We have 0 for an unmachined workpiece. We have the 1 if the workpiece holder, the slot is empty, and we have a 2. So we know that there's a machined workpiece in there. So we don't actually do machining here, right? It's just for the simulation purpose that we know which case we choose later on in our program to have it running properly. Then we have the variable chuck. Also, this will start here with an initial value of 0. The chuck 0 means it's closed and empty. 1 is available, so it's open and empty. Then we have a 2, which means we have a workpiece clamped, and that's it for the chuck. Then we have a variable for the machine. So for the machine, we have the 0, the initial value for ready. Then we have 1 for busy, that means it simulates the machining. 3 is the same, also busy for machining the workpiece. And 2 is finished half of the workpiece because we machine both sides of the workpiece. And the 4 is finally finished the complete workpiece. All right, let's have a look at the initialization. So what we've did here is we put a block comment. A block comment works as a kind of folder structure, so we can nicely hide everything this is put inside, right? It makes the program slim and nice in the initial case here that you can see. So we have only basically 3 lines in this program, but we'll see once we open up this, it will unveil quite a lot of commands underneath. So the initialization makes the station ready basically for the start. So we set everything according to what we want it to be in the beginning. Workpiece slots will be set to 0. So we have an unmachined workpiece there. Then we will open the chuck. We will set open chuck, you can see here. So what you will do, you put an alias if you want. It's easier to identify all the things later on. You can choose from this drop down here. Do we have a user I/O? Do we have the tool I/O? Is it a Modbus communication or a PLC, which is Ethernet IP? So we have here the user I/O. We choose the correct output, which is in this case 4, and we want to set it to high here so that we can open the chuck by this. After that, we will set the chuck variable to 1, so we know it's available, it's open and empty. Then we set the machine to 0, so the machine is ready to go in operation. And we set the gripper open. The gripper was the output number 3. This we set to high. So then we add here our home position. So a move command, move home, with 50% of the speed and acceleration. So you can change this here to whatever you want. You can see if I change it now, here's joint 1 chosen. So it will change only the joint 1 up here. If you want this to apply to all of the joints, you just click on share speed, and the 70 will apply to all of the joints. Okay, then we have taught the home position, the waypoint. You do this, all the waypoints. You go to set waypoint. Then you can control the robot over these fields of control, or you just press the free drive button and you drag the robot to whatever position you need. If you have very small adjustments to make, you can always activate the step mode and then put the parameters to how much you want one step to be, depending on the accuracy you need to apply. Okay, finally, after you have reached the waypoint, the position you want to apply, you click on confirm in the lower right corner, and again on to confirm here, which I will not do right now because I don't want to mess up my waypoint I've set up here. So I just click on somewhere else. Okay, next what we will do is open the door. So you have seen the nice door that we have here. So it's not an automatic door, it's a manual door, and the robot will take care of opening and later closing the door for us. So after that, we move back to our home position. This will be a position where we return to after every step we take. So we do one joint move close to the handle of the door. So one a bit further away to make sure we don't collide with anything, and then a shorter one to reach the final position, to finally open the door. We have here 80% of speed in there, and then we continue with a move line, which we have set to 15%. We want it to be a bit softer on the door while opening, and we have just one waypoint all the way up to where we want the door to be open. After that, we move back home to our home position. Here we only need one waypoint because the handle is on the other side, so we don't have the risk to collide with the handle of the door. That's for the initialization. After that, our main program, our main loop will start. So let's look into that. So basically we have 5 cases, but I wanted to show you different possibilities of how to realize these cases, these tasks. So I have combined 2 cases into one. This is to unload the machine. Case 1, let's start at the beginning. So case 1 is to load the machine with the workpiece from slot number 1. Case 2 is load the machine with the workpiece from slot number 2. Case 3 is swivel the workpiece, meaning the first machining operation is finished. We take out the workpiece from the chuck, turn it around, put it back inside. Case 4 and 5 are unloading the machine and put back the workpiece into slot 1 or slot 2. Okay, let's see how we have done that. So I will not go into every move command and so on again to save you some of your valuable time and not to repeat myself over and over again. So let's have a look. We go also through the home position again. We move to slot 1 also here. We have a safe position, only one basically, which we will approach with a move joint. And after that, to maybe a good information to tell you. We don't have a really nice picture of the gripper here, but we cannot approach the workpiece from here and go over it. So we need to go from top onto the workpiece and grip then, and then we need to go up again in the line to take out the workpiece from the holder. Okay, so this is why we have here move to the slot 1. We have a line move. So we just go down. Now this we have done with a position control, not the base. Basically, you can also use the base, but you can change the coordinate system here as well. So you have the chance to use the base or the flange center or your just created tool coordinate system or based on the tool coordinates. All right, then the next step will be to grip the workpiece. So this is a function that will be used over and over again, right? We grip the workpiece here, we grip it from slot 2, we grip it when it's in the chuck. So we have several scenarios where we use this. So, and we need to combine here 2 different commands. First, we set the output to low to close the gripper, and then we wait for a little time, here half a second, because we don't get a feedback. We don't have the inputs that give us the feedback that the gripper is closed or that we have gripped something. So we just wait for a little bit in order to make sure the gripper is closed before we move on with the next step. So after we've gripped the workpiece, we set the variable workpiece slot 1 to 1, which means it's empty now. We move back up in a line move to a safe space. We have it a bit higher speed in here. Then we move back to home position. So to be safe, be in a clearance, so to say. And then we move to the chuck in a safe space. So here we have the one safe position inside. What we've also done is for smoother movements, we have put in arrival ahead, because sometimes we have some obstacles close by. We have put it to a distance of 0.02 meters, so 2 centimeters here. This function triggers command, so the next move can start 2 centimeters before I reach the final waypoint where it shall go. 2 centimeters is rather safe here. Then we go on with a line move to load the workpiece into the chuck. And then we have a next block comment, right? Load the chuck. These are a few operations. So we set the chuck to close. So the output 4 will be low. We wait a short time, so the chuck is closed. And we need to open the gripper in the next step in order to release the workpiece into the chuck. We wait again half a second and we set the chuck to state 2, which means workpiece is clamped. So after loading the chuck, we move back to a safe position, also in line, because we have to move the gripper over the length of the workpiece into the clearance. Then we have closed door. It's also a set of commands grouped into the block command. We move to the home position. Then we move to the position of the door where it's open. So we have 2 waypoints in here. One, door open safe position, and then to approach the open door And finally, close it with a move line, 15% again of speed and acceleration here. After that, the door is closed. What now? The machining can start. So our simulation will start. In order to achieve this, we take the variable machine and calculate +1, which will increase, right, the variable by 1. So after that, we go into our home position and wait. Right? This is the first case. So that means the loop will start from the beginning. Oh, did I? I didn't. So exactly. So our condition for case 1 is we have a workpiece that is not machined in slot 1. So workpiece slot 1 is 0. Then the machine status must be 0, means it is ready. And the chuck must be 1, available, open, and empty. So the next case means, right, we take it from slot 1. The next case is a bit different. Also here, the machine must be 0, ready. The workpiece slot number 2 must be 0, so it's an unmachined workpiece. And also the chuck needs to be in 1, open and empty, so available. It's what I've done here. I copied all the commands from case 1 into here, so it's basically identical, just the moves depending to slot number 2, right, where I need to grip where I need to grip the workpiece are different, and I need to take care that also workpiece slot number 2 will be changed to 1 and not again slot number 1. Everything else is the same, so we can move to the next case. Case number 3. Here the machine state or variable needs to be 2. So before we added a 1 to it, so which means the variable changed from 0 to 1. So now, in order for this case to appear, it must be variable must be equal to 2, and the chuck must be 2 as well, which means we have a workpiece clamped. All right, let's look inside of that. So again, move home. Nothing happens usually with this first move. It's just to make sure that everything is fine. The robot should be in the home position anyways. We need to open the door now, because what we want to do with this case is we want to change the side of the workpiece, right? So turn it around, swivel it. So that means the machine gave us a signal that the machining is complete. So we need to open the door, right? Open the door. We discussed this in initialization, so we don't need to go into there. I just copied and pasted this one. So how you can do that? So if you have chosen this one, you just click on the copy sign here. Then you add a new command, condition. You can put an empty one. Empty one is quite nice because it's universal. You can copy any command into there. Click on copy, copy, and then we click on paste. Finished. So then we have 2 equal ones here. So we can either delete here with this sign, or we can go back to undo our operation 2 times, also to remove the empty one that we included. Let's continue. So we open the door, move back to our home position, then move again to our safe position of the chuck. It's the same like in case 1 and 2. We can reuse all these. Also the chuck, move chuck here to grip the workpiece. Right, we have a line move. Also I forget the L here, right? Unload chuck. This is new, all right. So we had the load chuck, right? So now we have unload. What do we need to do? It's the opposite direction. So I just copied and pasted the load chuck block comment I had before and rearranged the sequence in here. And first we need to close the gripper. Then we wait again. We open the chuck, wait for a second, and we set the chuck to 1. So then we have another block comment. So to swivel the workpiece, we move into a safe position and activate the swivel unit. We set it to high. The workpiece will swivel around and we can load the chuck again. So move back to the chuck, load it. This is just copy paste from above, right? And we put again the variable 2 for the chuck that it has a workpiece clamped. So, and again, the same procedure, move to the safe position, move back home. And what we do now, set the swivel off to have it in a normal position. We close the door, set the machine again +1, which then equals 3. Move back to our home. So 3 is again simulating the machining. Right, and then case 4 is unloading the CNC station. So there we need the machine state to be 4. The chuck needs to be, must have a workpiece clamped. And then, because here we combine workpiece slot 1 and 2, right? It can be either workpiece from slot 1 or slot 2. So one of the two, and either slot 1 must be empty, equals 1, or slot 2 must be 1, so empty. Let's see how we have done it here. So again, open the door, move back to the home position. We go into the safe chuck position, go into the chuck to grip the workpiece. We unload the chuck. We go into a safe position, move back home. And now, this is for both the workpieces, same workpieces. It's the same procedure. So we can put this for both cases. Then we need to decide, do we want to put the workpiece into slot 1 or into slot 2? So let's see. We just check slot 1. Is it empty? Then we go there. If not, we check slot 2. Is it empty? Or if slot 1 was not empty, we go to slot 2 and check this one. If this is empty, then we would go there. All right. So what do we do here? It's the opposite way of what we've done when we grip the workpiece from the slots. We move to the safe position, right? It's the same. Sorry, it's absolutely the same. Just we're not closing the gripper, but we're opening the gripper here, right? So we set it open, wait for a little bit, and then we set slot 1, 2 equals 2, which means we have a finished workpiece in here. Okay, and exactly the same for slot 2, just that we move to slot 2 here. So then we go home, and what we have here, if we want to have a continuous running system, I have another if function here. If both workpiece slot 1 and workpiece slot 2 equals 2, then we reset them to 0. because otherwise we would have two machined workpieces there and the program would end. Nothing else would happen anymore. We would stop in the else function here, where we just have a wait period of a second. All right, that's it about the main program. So now let's have a look at the thread. For everyone who doesn't know what a thread is a subprogram basically, which is running parallel to the main program. So there's usually a loop inside which runs through parallel at the same time to the main program. So this is running, this is running. So I use it here for the machine status. So we have a loop that's always running, and then we wait. We wait. It's a machine status, it's more or less the machining simulation, you can say. So because when we get the feedback that a machine status is 1 or it's 3, so it means 1 is after the unmachined workpiece is put into the machine, and 3 is after the workpiece is swiveled around, then the machining will start. And we just simulate this with a waiting time of 5 seconds here. After that, we increase the machine variable by 1. Just wait another 3 seconds, nothing will happen, but this already set, right? As soon as this is set, our case evaluation will continue and we will have the next case running. So, and then we say, okay, if the machine variable is 4, we want to reset it, right? Because we only count to 4, we need a 0 for the case to start again. So we set this back to 0, and then we have an else here, which is just a short waiting period. Okay, that's it. Now let's have a look at the running program. So we start the program, and the initialization is just right now happening with opening the door, and we start with case 1. So workpiece 1 will be loaded into the chuck, the door closes, and the machining will start. You can see on the upper right corner the AUBO PE, which steps are currently underway. This was case 3, to turn around the workpiece machine from the other side. What you see here right now is already an optimized program. So basically what you've seen in the programming part is the first draft, and while teaching the waypoints and after teaching the waypoints, you will see potentials for optimization, and we did this here already. We could reduce the cycle time from start to end of the project from 2 minutes 20 seconds to 1 minute and 35 seconds. So now, again, case 3, loading the workpiece number 2 that is inside here right now was the case number 2. Unloading is case 4 and 5, which is happening right now for the second workpiece. Fabulous. That's it. Thanks a lot for watching, and if you like the videos, give us a thumbs up, subscribe to the channel, leave us a comment. If there's something that we can improve, let us know. We're happy to work on it to make our videos serve you. I'll see you soon. Bye.